Hello, legacy students. So today we're going to write polynomial functions based on some descriptions we got. What you're going to want to have on you today, your notes, calculator, and then a pen or a pencil. So today, if you recall, when we looked at graphing quadratics, we had what's known as intercept form, which looked like f of x equals a, which was some number, and then x minus p and x minus q. Remember, P and Q were our intercepts. Well, in this section, what we're going to look at is how to write equations of cubic functions. So you'll have to add another factor. So we're going to have f of x equals a times x minus p times x minus q times x minus r, where p, q, and r are x-intercepts of the graph. Let's take a look at a couple of examples so you get an idea of how to do this. So, on this one, I have a graph here on the left-hand side, and I need to leave my answer in factored form. So you do not need to multiply this out to get an x cubed function, which is super awesome. So on here, it looks like I have x-intercepts at -3 here, one at 1, and one at 4, right? And then I have this really random point right here. We want that random point. It's going to be useful for us. So first things first, let's remember our equation here. Y equals a times x minus p times x minus q times x minus r. So now what I can now do is take my 3 x-intercepts here and plug that in for my p, q, and r. Now notice, guys, that it's basically however you would have solved to get that -3. So it would be x plus 3, because if I'd set that equal to 0 and solve, I would have gotten -3. So you're always going to want to put in the opposite into your parentheses when you make your factors, okay? Now, how can I get that a? Right now I have 3 variables, y, a, and x. Well, x and y are usually missing. We don't have usually a number for that, but we need a number for a. So that's when that random point's going to come in here. So I'm going to take my random point and plug in my 0 for my x and the -4 for our y. So I'll have -4 equals a times 0 plus 3 times 0 minus 1 times 0 minus 4. Now it becomes a simplification problem. So let's add each of the parentheses together. So I get a 3, a -1, and a -4. Then multiply everybody together. I should get 3 times -1, that's -3 times -4. We should get positive 12, right? Still solving for a though, so divide by 12 it looks like. I'll get -1/3, right? Because if I divide by 12, I get -4 over 12, which is -1/3, right? So now what I'm going to do is take that -1/3 right here and whoop, put it up there. So my equation for my cubic function in factored form, because it would be silly to multiply this all out, I will get y equals -1/3 times x plus 3 times x minus 1 times x minus 4. Let's try one more. So I just have some given points here. Leave your answer in factored form again. So I have -2, 0, 0, 0, 1, 0, and 2, 1. So very first thing, you're always going to want to figure out who's the intercepts and who's the random point. So the random point is 2, 1, of course, because it's not an x-intercept. So my x-intercepts are -2, 0, and 1. So now let's go ahead and plug it into our formula. Y equals a times x minus p times x minus q times x minus r. And remember, guys, it's going to be opposite. So instead of being x minus 2, it's going to be x plus 2, right? Then x minus 0, which is basically just x, but nevertheless, we need to have that -0 there. And then x minus 1. So now let's plug in our random point for our x and our y. So my y is 1. My a is, I still need it for my a. I have 2 plus 2, 2 minus 0, and 2 minus 1. Do the math really quick here. So 2 plus 2, we're going to get 4. 2 minus 0 is 2, and 2 minus 1 is 1. Let's do multiplication quick. 4 times 2, 8 times 1, that's 8. And then it looks like I got to divide by 8. So we'll get 1/8 for my A. So just like last time, we're going to take that 1/8 and whoop, put it right here. And you could write this two ways. So I could have it 1/8 times x plus 2 times x minus 0 times x minus 1. Or if that x minus 0 bothers you a lot, which for some people it does, you can not have the x minus 0. You can just have a plain old x sitting right there, and then it will be fine and perfect and dandy. Alright, so let's look at two more problems here. So I'm going to write a quartic function whose graph passes through the given points, and I'm going to leave my answer in factored form. So I have x-intercepts, one of them being 2 plus square root of 3, one being -1, and another one being 4. Now, something to keep in mind. Remember, guys, this 2 plus the square root of 3, you normally also got 2 minus the square root of 3, right? Keep in mind, if you have the positive version of that, you're also going to get the negative version of it as well, just because of how the square roots work. Then we also have a random point of 3, -4. So what I'm going to do first is I'm going to write out our x-intercepts, so that would be x minus, and then I'm going to have 2 plus the square root of 3, like that. And then I'm going to have 2 minus again, and then it's going to be 2 minus the square root of 3, like that. And then it looks like we have x plus 1, x plus 4. And we still have that a right here, or, oops. There we go. Still got a right here and y right there, right? So now, let's go ahead, these two pieces right here, let's get them so they don't have that 2 plus the square root of 3 business. It's kind of icky. This piece we can kind of leave. But let's figure out what this is actually going to turn into. So, it looks like I have to, first I'm going to distribute. So it's going to be x minus 2 minus the square root of 3. And then it looks like I get x minus 2 plus the square root of 3, right? Because if I just distribute that negative in. Now, these two have to be multiplied by one another. So what we're going to do is multiply the x in all the way, the 2 in all the way, and then the square root of 3 in all the way. So x times x, I'm going to get x squared. X times -2, that's -2x. X times the square root of 3, that is x times the square root of 3, x square root of 3. Okay, let's do the -2. So -2 times x, that's -2x. -2 times -2, that's positive 4. And -2 times the square root of 3, that is -2 square root of 3. Whew, we're almost there. Negative square root of 3 times x, that is a -x square root of 3. Positive 2 square root of 3. And then negative square root of 3 times the square root of 3, that is a negative square root of 9. Right? Which we know that's just 3. Now, let's see if stuff cancels out. I get x square root of 3, positive, and a negative. They're gone. -2 square root of 3, positive 2 square root of 3. That's gone. Looks like I can combine some numbers here. So we get x squared. I have a -2x and another -2x. That's a -4x. 4 minus 3. That is a positive 1. So this piece right here, that's what generated this up here, which was gross. But now this is actually the factor with that. So then I got x plus 4 there. Still got an a. And we got y. Now I can plug in my random point of 3, -4. So my y is -4. Don't know a. But my x is 3. So I'm going to get 9 minus, it looks like 12 plus 1. And then 3 plus 1 and 1 plus 4. Nope, 3 plus 4. My bad. 3. There we go. So I'm going to get -4 equals a times, what do we got got here? Negative 3 plus 1, that's a negative 2. It's a 4, and that's a 7. So if I multiply, we're going to get negative 56. Right? Negative 2 times 4 is negative 8, times 7 is negative 56. Divide by negative 56 to solve for A. It looks like A is equal to, which 4 and 56 can both go in with a 4. I can divide by 4. So that would be 1 over 14 for my A. So what I'm going to do is I'm going to plug that in right there for my final answer. So y equals 1 over 14, x squared minus 4x plus 1, x plus 1, x plus 4. Now, ultimately, guys, to actually get the quartic equation, like with the x to the 4th, you would multiply this all out. However, since Marcia's feeling nice, you're not going to have to. Alright, let's try the last one here. So, I have the x-intercepts of negative 1. Now it means twice. That means negative 1 is a twice intercept, which means basically it has, when I factor, it's going to be x plus 1 and x plus 1 twice. And then I get 3i, imaginary numbers. But now remember, guys, we always had a positive imaginary number and a negative. So we also are going to get net negative 3i. Now I have a random point of negative 2 and 26. So let's go ahead and write out here. So we have a. Let's write our twice negative 1, so that would be x plus 1, another x plus 1, right? And then we get x minus 3i, and x plus 3i. Okay, I'm just going to leave this kind of hanging over here. Let's go ahead and multiply this out. So x times x is x squared. X times 3i, that's just 3ix. I get negative 3ix. Notice how that's canceling. And I get negative 3i times 3i. That's a negative 9i squared. So, remember, guys, I squared was just negative 1. So I get negative 9 times a negative 1, which is just 9. So I get x squared plus 9 right there. Then I still have this x plus 1 times x plus 1, which you could write x plus 1 squared if you want. Like that. Now I'm down to not having imaginary or square root in my factored form. So let's plug in our random point. So we got 26 equals a. Negative 2 plus 1, that's negative 1. Again, another negative 1. Be 4 plus 9, so that's 13. So I get 26 equals negative 13 times a. So let's divide. Looks like we're going to get a nice a this time. A looks like he's going to be negative 2. So if I write my final answer, y equals my a, which is negative 2. I get x plus 1. I'm just going to write x plus 1 squared, since it's written twice. And then x squared plus 9. Dunskies. And that's the end of this video. See you later, Sabers.